Hello friends, in today's question, in the situation shown in the figure, for what value of f sliding between middle and the lower block will start. So there are three blocks, 2 kg, 2 kg and 4 kg. Force F is being applied on the middle block, that is 2 kg. And the coefficient of friction between is given as 0.1, let us call it mu1, mu2 and mu3. It is given as 0.1, 0.6 and 0.2. So let us first of all draw what will be the various frictional forces and how they will be acting with respect to each other. This is our 2 kg block. This is the middle one, 2 kg block. Force F is being applied on it. And this is our lower, last one. And this is 4 kg. Now this 2 kg block will try to move this upper along with it with the frictional force Fr1, and equal and opposite will be acting here also, Fr1. Similarly, this 2 kg will try to move the 4 kg along with it, so let us call this Fr2, and equal and opposite will be acting here also, Fr2, and the friction between the 4 kg and the surface or ground, let us call that Fr3. So these are the various frictional forces that will be acting on it, and let us find out what will be the limiting value or maximum value for each of the frictional force. So we can say Fr1 max will be equal to mu1, and let me draw it here. This is a 2 kg block. We have Fr1, and here will be let me call it 2g directly, and there will be normal, let us call this normal n1. So mu1 n1, and n1 is equal to 2g, so we can write mu1 is 0.1 into 2, g is 10, so we get maximum value equal to 2 Newton. Okay, and for Fr2 max, so this is middle one 2, and it will be here also 2 kg, the above one, so this will be 4 kg, 4g. Okay, and let us suppose there is a normal n2 acting on it, so we can say that F2 max will be mu2 into n2, which is equal to mu2 is given as 0.6, and this is 2 plus 2 4 into 10, so we are going to get this as 24 Newton. And similarly we can find out for the last one. So this will be 2 kg, 2 kg and 4 kg. So in the downward direction there will be a total of 8g, and let us suppose normal is n3. So you can say that our F3 max is equal to mu3 into n3. Value of mu3 is 0.2, and this is 8 into 10, so we get this is m3 max will be equal to 16 Newton. So these are the maximum value of the frictional force that will be acting on the respective blocks. Okay, now next let us find out what will be the accelerations of the blocks. Okay, so we can say for block 2 kg, So we have, this is 2 kg block FR1, and let us say it is moving with the acceleration of AA. Okay. Now 2 kg block is moving because of the frictional force that is being applied on it. Say block 2 kg moves because of frictional force FR1. So therefore acceleration of this block will be given by FR1 divided by its mass, that is 2, and FR1 will be equal to FR1 max because it is already moving. FR1 max, which is equal to 2 Newton. So this will be equal to 2 upon 2, and we are going to get this as 1 meter per second square. This is the acceleration of block A. Now let us find out what will be the acceleration of 4 kg block. So say for block 4 kg, this is a 4 kg block. Force of friction FR2 is being applied on it. Let us suppose it is moving with acceleration AC in this direction. Okay. You can see block 4 kg will move because of frictional force FR2, and I forgot to mention here frictional force FR3 in the opposite direction. Okay, so we can say that it is sliding, so we can say FR2 will be equal to FR2 max, and FR2 max is 24 Newton, and similarly FR3 will be equal to FR3 max, which is equal to 16 Newton. And so acceleration of C will be equal to FR2 minus FR3 divided by so it is given as 4. So we have 24 minus 16 divided by 4, and we get this as AC will be equal to 2 meter per second square. Now if we compare the accelerations of block A and block C, okay, you can see comparing acceleration of block 2 kg, that is acceleration A, with acceleration of block 4 kg, that is AC, you can clearly say that acceleration of A, that is 2 kg, is less than acceleration of block 4 kg. So this basically means block 2 kg will reach its maximum acceleration before block 4 kg. And from here we can also draw a conclusion that if this condition persists, then slipping between A and B will start first, slipping between block 2 kg, that is upper, and 2 kg block, that is middle one, middle block will start early, then between 2 kg, that is middle block, and block 4 kg, that is the lower block. So under this condition, we already said that block slipping between, let me draw it here. So this is 2 kg block, the upper one, and this is 2 kg, the middle block, and this is our 4 kg, the lower block. So this is our upper block, this is our middle, and this is the lower. So as the slipping between upper and middle will start early rather, so it means this middle and lower will be traveling together a little bit more as compared to the upper block. Okay. So you can say block 2 kg, that is middle one, middle block will move with block 4 kg, that is lower one, lower block little bit more, a little longer rather, than other one. Excuse me. So in simpler terms, we can say that middle order block as well lower order block will move together. You can say that middle block, which is 2 kg, and lower block, which is 4 kg, will move together. So we can draw this thing with the help of like this. So we just concluded that block A will move early and block B and C will move together. There will be minor difference between the separation. And force F is being applied on this. We have a frictional force FR1. This will be also FR1, and this will be our FR3. So therefore, we can say that the applied force F F minus FR1 minus FR3, and this is 2 plus 4, and the acceleration is 2. So this will be coming equal to as 16. From here we can say that F will be equal to 12 plus, okay, and one thing more, they are slipping, FR1 will be equal to FR1 max, and FR3 will be equal to FR3 max. Excuse me. So we can put the values 12 plus 2 plus 16. So from here we can say that the force F will be equal to 30 Newton. Okay. So for this value of force 30 Newton, let's find out what will be the acceleration of block B. Okay. So for F is equal to 30 Newton, the acceleration of block B, let us suppose that is given as A1, or rather AB. So this is block B, it is moving with extension AB, applied force is F, and we have a friction force FR2. So we can write the equation as extension AB will be equal to applied force F minus FR2, and its mass is 2 kg, is 30 minus 24 divided by 2. So from here we can say that acceleration of block B will be equal to 6 divided by 2, that is 3 meter per second square. But we already know that maximum acceleration for block C AC, which is given as 2 meter per second square. Therefore, as we can clearly see, the acceleration of block B is different or greater than block C. So from here we can say that as acceleration of B is greater than acceleration of C, at force F is equal to 30 Newton, slipping between block B and block C will start. Okay, so final answer will be the applied force F is equal to 30 Newton. Okay, so this is the final answer. Basically, it is a MCQ type question, and in that case